we are going to revise the lesson continuity. We say that a function is continuous at x is equal to a when limit extending to a of f of x is equal to of a itself. Or we can split this limit as limit extending to a minus of f of x should be equal to limit extending to a plus of f of x equal to f of a. We call this as left hand limit and this as right hand limit equal to f of a. If all these three quantities are equal, we say that the function f is continuous at x is equal to a. So graphically, there is no break in the curve at x is equal to a. It is a continuous function. There is no break at that particular point. That is the meaning. For which questions we have to do LHL or HL? For example, greatest integer function questions. We denote the greatest integer function by square brackets. Signum function, absolute value of x by x. This particular signum function has discontinuity as 0. We know that. And then absolute value function. But absolute value function is always continuous. And fourth, if f of x is defined as two different definitions are given, for example, f for x less than or equal to 2 and for x greater than or equal to 2. So at 2, we do LHL and RHL to check the continuity at 2 and etc. For these four functions, usually we do LHL and RHL. If f and g are continuous functions, then f plus g, f minus g, f into g, f divided by g provided g is not equal to 0, and f composite g. All these functions are also continuous. If you have limit extending to a of f of x plus g of x, we can distribute the limit and we can find extending to a of f of x plus limit extending to a of g of x. Similarly, for subtraction, for multiplication also we can separately apply the limits if both exist. For division, again, we can apply the limit for the numerator, apply the limit for the denominator if both the limit exist. Composition of two functions, if both are continuous, composition is also a continuous function. While applying the limit value in the given function, we should not get 0 by 0 form or any constant by 0 form or infinity by infinity. These forms we should not get. We should try to avoid getting these forms. By doing factorization, we can avoid such forms by doing factorization or rationalization. When do we do factorization? When the given function is a rational expression. And when the denominator becomes 0, you can factorize, cancel the common factor and apply the limits. Or we do rationalization. Rationalization we apply when two terms are under root or one of them under root and the denominator becomes 0. We use rationalization. Or in some questions we use substitution method. We can apply the formulae also, formula method. So one of these four methods we use. In case if we get one of the above form, 0 by 0 form or some constant by 0 or the infinity by infinity form. Now formulae, we will revise the formulae which we learnt in 11th standard. Limit extending to 0 of sin x divided by x is 1. Similarly, limit extending to 0 of tan x by x is also 1. third formula. Limit x tending to 0 of 1 minus cos x divided by x becomes 0. This formula cannot be applied in the denominator because denominator cannot become 0. Only in the numerator we can use that. But remember, all trigonometric functions can be solved by this first formula. All limit questions involving trigonometric functions can be done by that one formula. Then we had limit x tending to a of x power n minus a power n by x minus a is n into a power n minus 1. Then limit x tending to 0 of log of 1 plus x by x is 1. Limit x tending to 0 of e power x minus 1 by x is 1. Okay, let us do this question. Find all points of discontinuity of f of x, which is modulus of x by x where x is not equal to 0 and 0 when x is equal to 0. In this question, it is not mentioned at which point we have to check the continuity. So we have to do at all points, but the definition is given at 0. So let us check first at 0. At x is equal to 0, we are going to check the continuity. Since it is a signum function, I am going to do LHL and RHL. Limit x tending to 0 minus of f of x. X tending to 0 means it is not equal to 0. Okay, it approaches 0, either from the right side, left side of 0 or from the right side of 0. That is the meaning. Absolute value of x by x. Now we have to remove the absolute value sign before applying the limit. We know the definition of absolute value function. It takes the value x itself when x is positive, or it becomes minus x when x is negative. X is negative. By writing minus sign, we are making it positive. Limit x tending to 0 minus. I am going to remove this absolute value. Absolute value of x. Here x is tending to 0 minus. That is approaches 0 from the negative side of 0. Therefore, I have to write minus x because my x values are all negative. To make it positive, to remove the absolute value sign, I have to write minus x. And the answer is minus 1. It is given that f of 0 is 0. Here, see the definition. Now we can say that LHL is not equal to f of 0. We need not do RHL in this case. These two are not equal. Therefore, we can conclude that f is discontinuous at x is equal to 0. We have to check for other real values. Case 2 we will take. I will take C belonging to minus infinity to 0. 0 is not included because already we checked at 0. So we will check for negative real values. Limit x tending to C of f of x. Limit x tending to C of absolute value of x by x. Now I know for sure that my C value is negative. C is taken from the negative side. So C is negative, we know. I can write this as minus x by x to remove the absolute value sign. Or you may use H method. So the answer is minus 1. And f of C I have to calculate, which is absolute value of C by C. Again, C is negative in this case. I can write it as minus C by C. That is the definition of absolute value function, which gives you minus 1. These two values are equal. Therefore, f is continuous for all c belonging to minus infinity to 0. Now case 3. We will check for positive real values. We will take c belonging to 0 to infinity. Limit extending to c of f of x will be limit extending to c of absolute value of x by x. I have to remove the absolute value sign, but my all c values are positive. I know absolute value of x is x itself for positive values. Therefore, the answer is 1. Let us calculate f of c, which is absolute value of c by c. And we know that c is positive because it lies in this interval. C is positive, so absolute value of c is c itself. Both these values are same. Therefore, I can conclude f is continuous for all c belonging to 0 to infinity. Now, from all the 3 cases, the only point of discontinuity is at 0. Therefore, f is discontinuous at x is equal to 0. Next question. Let us consider the function g of x is equal to x minus greatest integer function of x. We have to show that it is discontinuous at all integral points. Let us take c as an integer. Z is set of all integers. Let us calculate LHL. Limit extending to c minus x minus greatest integer function of x. C is an integer here. C minus means it tends to c from the left side of c. The greatest integer function should give you a value, an integral value which is less than or equal to the given number. It should not be, it can be equal to the number, it cannot be more than that. For example, greatest integer function of 2.5 is 2. 2.9. Greatest integer function gives you 2. We don't round it off. For negative values, the lesser integral value you have to give, which is minus 3. So it becomes c minus 1 here, which is equal to, this x is c, but greatest integer function of this becomes c minus 1. Which is equal to c and c are getting cancelled, we get 1. Now let us calculate RHL. RHL will be limit extending to c plus, which is equal to, for x the limit tending to c is c itself, minus c plus. C plus means approaching c from the right side of c. For example, the values on the right side of c say, the greatest integer function becomes c. The lesser integral value you have to give. The answer is 0. So LHL not equal to RHL. So we say therefore g of x is discontinuous at all integral values. Next question. F of x is equal to x square into sine 1 by x when x is not equal to 0 and 0 when x is equal to 0. Check whether f of x is continuous or not. We can combine LHL and RHL as x tending to 0. Even if you do separately, you will get the same answer. X square into sine of 1 by x, which is equal to, it is product of two functions. I can apply the limits separately. Now this becomes 0. Here, as x approaches 0 from the left side, this becomes 1 by x becomes infinity, plus minus infinity. If it approaches from the right side, it's a very big answer, positive or negative. Approaching from the negative side means very big angle, negative angle. Here very big angle, positive angle. Whatever the angle is, sine do exist for all angles. We don't have not defined case for sine. So we get some value between -1 and +1. So 0 into any number, the answer becomes 0. And f of 0 is also 0 given in the question. Therefore, f is continuous at x is equal to 0. Now we have to check for other values, because it is not mentioned in the question at which value you have to check the continuity. Now next case is, we will take any value c, any real value other than 0, because we already checked at 0. Positive or negative, we are combining. Limit extending to c of f of x will give you limit extending to c of x square into sine 1 by x, which gives you c square into sine 1 by c. And f of c is also c square sine 1 by c. Both are equal. Therefore, f is continuous for all c belonging to r minus 0. So from the above two cases, we can conclude that f is continuous everywhere. Okay, next question. F of x is defined like this. Find a and b if f of x is continuous at x is equal to 4. So it is given in the question that it is continuous at x is equal to 4. We know that LHL must be equal to RHL and equal to f of 4. Let us do LHL. Because the definition is less than 4, greater than 4, two different definitions are given. Limit x tending to 4 minus. For 4 minus we have to use less than x, less than 4 definition, which is x minus 4 by absolute value of x minus 4 plus a. Now I am going to remove the absolute value sign by checking whether the function is positive or negative in that interval. It tends to 4 from the left side of 4. For example, let us take a very close value 3.9. 3.9 minus 4 is negative. So for negative values, we write minus sign to remove the absolute value sign. Already x minus 4 is negative. By writing minus sign, we are making it positive. This becomes a constant. So the answer is minus 1 plus a. Same way, let us do RHL. Limit extending to 4 plus. For 4 plus, we have to use greater than 4 definition. This definition should be used. Now, in this case, it tends to 4 from the right side, 4 plus. If you take 4.1, 4.1 minus 4 is a positive quantity. So x minus 4 is positive in this case, we know. Since it is positive, we can remove the absolute value sign. It becomes a constant 1 plus b. So this is RHL. Since f of x is continuous at x is equal to 4, LHL equal to RHL equal to f of 4. We got LHL answer as minus 1 plus a, RHL as 1 plus b, and f of 4 is given in the question as a plus b. Let us take these two. A will get cancelled. We get b is equal to minus 1. Now let us take these two. B gets cancelled. We get the answer for A. So we found A and B values. Next question. F of x is defined like this. It is given that it is a continuous function at x is equal to 0. We have to find A, B and C values. Since we have less than and greater than two different functions, we will do LHL and RHL. Limit extending to 0 minus. For 0 minus, we use less than 0 definition, which is sine of a plus 1 into x plus sine x divided by x. We will separate the terms. To apply the limits, we have a formula, limit extending to 0 of sine x by x is 1. We are going to multiply and divide by a plus 1. We have sine of a plus 1 times x, so we need the same angle in the denominator, a plus 1 times x. So let us multiply both numerator and denominator by a plus 1. Now we can apply the limit formula. As x tends to 0, a plus 1 times x also tends to 0. So the formula is applicable for the first term. This becomes 1 by this formula. A plus 1 into 1 plus limit extending to 0 of sine x by x is 1. The answer is a plus 2. Now RHL, limit extending to 0 plus. For RHL, we use greater than 0 definition, which is root of x plus bx square minus root x by bx root x. Here one x is common. I am taking x outside the expression but keeping it inside the square root. Now in the numerator, square root of x is common. We are able to get rid of this root x. Now we have to get rid of this x term also. Because of that x term only, we are not able to substitute the limit value. In this case, we are going to use rationalization. If you have one of the terms or both of the terms under root sign, and if you get not defined case, we use rationalization method. Here we are going to rationalize the numerator. This is the rationalizing factor. A minus b into a plus b becomes a square minus b square by bx into root of 1 plus bx plus 1. 1 could be cancelled. Now bx and bx also could be cancelled. Let us apply the limits. 1 by root 1 plus 1, which becomes half. Since the function is continuous, LHL equal to RHL and equal to f of 0. LHL answer is a plus 2. RHL is half and f of 0 is C. A is half minus 2. Half minus 2 is minus 3 by 2 and C value is half. In this we don't have B. So it doesn't depend upon B. That means B can take any real value but not 0. Why not 0? Because the function is defined as this, where B is given in the denominator. B is given in the denominator, so B cannot take the value 0. Other than 0, B can be any real value. Next question, f of x definition is given and it is continuous in the interval minus 1 to 1. Find P. So it is continuous at 0 also. Since the definition has been split at 0, we will check the continuity at 0. LHL is limit extending to 0 minus. For 0 minus, we use less than 0 definition. This definition we use root of 1 plus px minus root of 1 minus px by x. We are not able to substitute the limit value 0 because the denominator becomes 0. We are going to use rationalization method because we have two root terms. Rationalizing factor is this. Limit extending to 0 minus a minus b into a plus b is a square minus b square divided by x times this factor. One could be cancelled. Now numerator is 2px divided by x times root of 1 plus px plus root of 1 minus px. Cancel x term. Now I can apply the limits. 2p by x is 0. 1 plus 0, 1. Root 1 is 1. 1 plus 1 becomes 2. Let us find RHL. 0 plus. For 0 plus, the definition is so simple, so easy. Look at the denominator. The denominator doesn't become 0 if you substitute x as 0. Therefore, direct substitution. X is 0, whether it is approaching from the right side of 0, so 1 by minus 2, which is minus half. The function is continuous, so LHL equal to RHL equal to f of 0. P is equal to minus half, and f of 0, if you substitute 0 in 2x plus 1 by x minus 2 also, you get minus half. So P's answer is minus half. Next question, f of x definition is given and it is continuous at x is equal to 0. We have to find the value of a. Let us first find LHL. Limit extending to a minus, that is 0 minus. We are checking the continuity at 0. I have to use less than 0 definition, this definition. A sine pi by 2 times x plus 1. There is no denominator becoming 0. Directly we can substitute. It is so simple. Sine of 0 plus 1, which is 1 into pi by 2. Pi by 2. Sine 90 is 1. The answer is A. RHL limit extending to 0 plus. I have to use greater than 0 definition. The denominator is x cube. If the denominator is x, I could have split the function into 2 and we can use the formula. But here it is x cube. So let us simplify the numerator by substituting tan x as sin x by cos x. Let us take LCM. And in the numerator, sin x will be common. We will get 1 minus cos x. Limit extending to 0 plus. Use the formula of 1 minus cos x. 1 minus cos x is 2 sin square x by 2 divided by x cube into cos x. I am going to split that x cube as x into x square. I have sin square x by 2 by x square and 2 by cos x. I am writing x cube as x into x square, and I have written all the other functions. Sin x by x. I can write this as sin x by 2 by x by 2 the whole square and 2 divided by cos x. Here I have divided the denominator by 2 square, which is 4, this 2 square. So I have to multiply the denominator by 4. Now let us apply the limits. Sin x by x as limit extending to 0 becomes 1 into 1 by 4, and sin x by 2 is also 1 square, which is 1. 2 by cos 0 is 1. The answer is half. Now it is a continuous function, so LHL must be equal to RHL. A must be half. Next question, f of x definition is given and the function is continuous at x is equal to 0. We have to find the value of k. In this question, we need not do LHL and RHL. We can combine both as limit extending to 0 of f of x. Limit extending to 0 of f of x is log of 1 plus 3x minus log of 1 minus 2x divided by x. Limit extending to 0 of, let us split this into two terms. We are going to use this limit formula. Limit extending to 0 of log of 1 plus x divided by x is 1. To use this formula, we will write this as log of 1 plus 3x by x. We will multiply both numerator and denominator by 3. Similarly, the formula has plus sign, so I will write it as minus 2 times x by x. For this term, I will multiply by minus 2. Now, as x tends to 0, 3x tends to 0, I can use that formula. Therefore, this becomes 1 by this formula. This also becomes 1 by the same formula. It is 3 into 1 and minus of minus 2. The answer is 5. And in this question, f of 0 is given as k. So both must be equal because it is a continuous function. Therefore, k value is 5. Next question, f of x definition is given and it is continuous at x is equal to 0. We have to find the value of a. Here the definition less than 0, greater than 0, two different definitions are given. We need to do LHL and RHL. Limit extending to 0 minus. For 0 minus, I'll be using less than 0 definition, which is 1 minus cos 10x divided by x square. If you split the x square as x and x, we cannot apply that 1 minus cos x by x formula, because here the denominator is x square, so we will simplify the numerator. If it is x, we could have used the formula directly, but it is x square. The numerator 1 minus cos x formula is 2 sine square half of this angle, which is 5x. I can write this as 5x the whole square. I have written 5 square here extra. I have divided by 25. So I am multiplying by 25. And 25 into 2 gives you 50. By the formula, limit extending to 0 of sin x by x is 1. Therefore, it becomes 50 into 1. And it is given f of 0 as a. We need not calculate RHL in this case. LHL must be equal to f of 0. So a is equal to 50 we can write. Even if you do a RHL, you will get 50 as the answer. In this question, the question says that it is continuous. So all three must be equal. These two are also must be equal. So directly we can write the answer. Next question. F of x is defined. The function is given, is continuous at x is equal to pi by 2. Find a and b. Since the definition is for less than pi by 2, greater than pi by 2, we have to do LHL and RHL. Limit extending to pi by 2 minus. Let us use less than pi by 2 definition, which is 1 minus sine cube x divided by 3 cos square x. One minus sine cube x divided by, I can write cos square as 1 minus sine square x, identity. I'm going to use factorization method here. I'm going to factorize the numerator using this factorization formula. And denominator a square minus b square factorization formula. A minus b into a plus b. Limit extending to pi by 2 minus. The numerator becomes 1 minus sin x into a square term plus ab term plus b square term divided by 3 times 1 minus sin x into 1 plus sin x. One minus sin x common factor can be cancelled. Limit extending to pi by 2 minus. If you substitute x as pi by 2, it gives you sin 90 is 1. 3 by 3 into 2, which is half. Let us do RHL. Extending to pi by 2 plus. For pi by 2 plus greater than pi by 2 definition I am using. Here, if you substitute the limit value in the denominator becomes 0. So we cannot apply the limit. I am going to use substitution method. We will take pi by 2 minus x as t. Or you may take pi minus 2x also as t. Same thing. You can use any one of these two substitutions. As x tends to pi by 2, t tends to 0. Let us substitute limit x tending to pi by 2. We will change it to t. So t tending to 0, b into 1 minus sine x is pi by 2 minus t. Divided by pi minus 2 times x is pi by 2 minus t. So pi minus pi plus 2t becomes 2t the whole square. Limit t tending to 0 of b into 90 minus theta. Sin 90 minus theta is cos theta. So cos t divided by 4t square. 1 minus cos t is 2 sin square t by 2. You have to be thorough with all trigonometric formulae. And this can be written as 2b sin t by 2 by t by 2 the whole square. That is, we have written 2 square here. So I need to multiply by 4, which becomes b by 8. Now since the function is continuous, RHL, LHL and f of pi by 2, all three must be same. LHL is half, RHL is b by 8 and f of pi by 2 is a. So we get b is equal to 4 by using these two and a is half. These are the answers. Next question, f of x definition is given. Show that f of x is continuous at x is equal to 0. This is an easy question. Let us do LHL. This is limit extending to 0 of, I am going to divide the numerator by 3x and multiply by 3x. Similarly, I am doing the denominator, multiplying and dividing the denominator by 2x. Or you can multiply only by the constant xx. Here x and x are getting cancelled. Applying the limit formulae, I am writing the limit formulae here. Limit extending to 0 of sin x by x is 1 and limit extending to 0 of tan x by x is also 1. The numerator becomes 1 into 3, denominator is 2 into 1 into 2, which is 2. Similarly, we can do RHL. Limit extending to 0, this is 0 minus 0 plus 1 plus 3x log of 1 plus 3x by e power 2x minus 1. multiplying and dividing the numerator by 3x and denominator multiplying and dividing the denominator by 2x. X and x could be cancelled. We have limit extending to 0 of log of 1 plus x by x is 1, and limit extending to 0 of e power x minus 1 by x is also 1. We are going to use these two limit formulae, 1 into 3 by 1 into 2. And f of 0 is also given as 3 by 2. All three are equal. Therefore, we can conclude that f is continuous at x is equal to 0. Next question, f of x definition is given. Show that f is discontinuous at x is equal to 0. For this question, we have to do LHL and RHL. Let us first calculate LHL, limit extending to 0 minus e power 1 by x minus 1 by e power 1 by x plus 1. Now, you should know that as x tends to 0 minus, 1 by x tends to minus infinity. We are dividing by a very small negative value. So, the answer will be very big negative value. So, what happens to 1 by x in that case? It becomes e power minus infinity, which can be written as 1 by e power plus infinity. 1 by infinity can be written as 0. Again, I am repeating, 1 by infinity can be written as 0. You should try to get infinity in the denominator so that we can substitute that as 0. You should not get infinity in the numerator, which is equal to, again I am explaining, as x tends to 0 minus, 1 by x tends to minus infinity. So, e power 1 by x tends to e power minus infinity, which can be written as 1 by e power infinity. 1 by infinity can be written as 0. E power infinity is also infinity. So, it becomes e power minus infinity, which can be written as 0. Directly I will substitute 0 minus 1 by 0 plus 1, which gives you minus 1. I need not calculate RHL because f of 0 is 0. They are not equal. Therefore, f is discontinuous at x is equal to 0. In case, if you are calculating RHL, say, how to calculate RHL, I will explain. X tending to 0 plus, the function is e power 1 by x minus 1 by e power 1 by x plus 1. What happens as x tends to 0 plus? 1 by x tends to infinity. So, e power 1 by x becomes e power infinity. E power infinity is infinity. I told you, you should not get infinity in the numerator. So, you get infinity minus 1 by infinity plus 1, which is infinity by infinity. It is not defined. I told you to get infinity in the denominator. So, what we are going to do is, we will divide both numerator and denominator by e power 1 by x. It becomes limit extending to 0 plus 1 minus 1 by e power 1 by x, 1 plus 1 by e power 1 by x. Now you get 1 by e power infinity. which can be taken as 0. Therefore, write this explanation. Therefore, it becomes 1 minus 0 by 1 plus 0. Or you may use H method. For x, you have to substitute 0 plus H. You can do by that method also. Equal to 1. In case if you want to do RHL, this is how we do. That's all for this class. Bye-bye.